An introduction to public safety DAS. Public safety revolves around the signal needed for the first or emergency responders. According to Wikipedia, a first responder is a person who is likely to be among the first trained people to arrive at and assist at the scene of an emergency such as an accident, natural disaster, or terrorist attack, etc. While a typical DAS design covers the usual areas we use during the day, for example, office rooms, meeting rooms, break rooms, etc., these are not always the areas where emergency responders are during a crisis. Many times they are trying to get to hard to reach and uncommon places such as equipment rooms, basements, stairwells, and elevators. It is essential that their communication devices continue to transmit in hard to reach areas. Newly built LEED or LEED certified buildings with low E-glass windows often suffer from poor public safety signal coverage due to signal attenuation caused by this special kind of glass windows. This is something we'll have to take care of as engineers when we're designing public safety DAS. Now, before we talk about building a public safety DAS, let's quickly go over the public safety frequencies that are used in a DAS. FCC lists the following frequencies for public safety spectrum. No need to memorize this table. Out of these bands in the table, common bands used for public safety are VHF, UHF, 700 and 800 bands. You don't need to remember all of these frequencies. Your local fire department will be able to tell you what's in use in the area. Public safety DAS can be built in both DAS 1.0 or DAS 2.0. Remember DAS 1.0 is all coax based. Here I'm showing a line diagram of DAS 1.0 and a simple visual representation how it's placed inside a building. Signal source for public safety DAS will almost always be repeater based. Repeater will be connected to a rooftop antenna facing a nearby public safety tower. You will also remember DAS 2.0 is coax and fiber based. You have seen this generic DAS 2.0 line diagram before. Regardless of the manufacturer, if it's a DAS 2.0, the core architecture will be very similar to this. Also showing a simple visual representation how it's placed inside a building. Whether it is DAS 1.0 all coax based or DAS 2.0 fiber and coax based depends on the size of the building. Bigger the building, more antennas we need. I can't give you any hard and fast rules, but it's safe to say smaller buildings which are less than 400,000 square feet in this area can be covered with all coax or DAS 1.0. Larger buildings, say within million square feet or bigger, may need active DAS or DAS 2.0, which involves fiber and coax DAS. Actual determination will be made by the engineers after they do their analysis. With that said, a quick disclaimer, the buildings with the systems shown on this slide are not scaled properly and for visual purpose only. So a smaller building does not mean it has 3 floors and can be covered with 6 antennas. Similarly, larger buildings may not be 5 floors and may not be covered with 5 remotes and 10 antennas. Just keep that in mind. But the bigger message here is that public safety DAS can be both just coax based or fiber and coax based. We haven't seen a whole lot of DAS 3.0 for public safety DAS, but it's coming.